There are different ways to source and use your hockey data. When you're first starting out, it's perfectly fine to manually download your data from whatever source you can find, for example NHL.com or hockey-reference.com. As you get more comfortable programming, you'll want to automate the process of sourcing your data to save you time and effort. In this lecture, we'll cover off on both manual and programmatic sourcing of hockey data. After this lecture, you'll be well prepared to decide which approach you want to start off with in this project.
In this lecture, we're going to focus more on getting the data. We'll use team stats data as the example data source in this lecture, but we've posted Excel CSV files in the course resources section that you can use for both the team and player stats data retrieval. In this lecture, we'll walk through 3 ways to obtain hockey data for use in your hockey analysis. 1. Manually exporting the data from NHL.com. 2. Manually downloading the data from mysportsfeeds.com. 3. Programmatically accessing the data using a web-based API from mysportsfeeds.com. The third of these methods uses Python and requires some programming skills, so if you just want to get the data and explore that data in Power BI, then you can feel free to skip the third part. However, if you're interested in doing more with hockey data, potentially even coding up your own analytics application, then don't miss learning how to programmatically access the data via API and Python. Overall, this lecture provides you with an overview of the different methods for obtaining hockey data, as well as practical skills for using APIs and Python to process and store the data. The first method we'll walk through is exporting team stats data from NHL.com. We need to note that when you use data, or software for that matter, from NHL.com, you can only use it for non-commercial usage unless you have a license that states otherwise. The export feature on NHL.com provides a convenient way for users to download different types of hockey statistics for use in their analysis. The process of downloading statistics is relatively straightforward and can be completed in just a few simple steps. To begin, users should navigate to the NHL.com stats page, for example, nhl.com/stats/teams, and select the desired category of statistics, such as player or team statistics. From there, users can filter the statistics to display only the data that's relevant to their analysis, such as specific time periods or specific players or teams. Because we're in the playoffs as we write this course, the default data will be playoff statistics. So use the filters on the page to select the specific data you want to export. Once the desired statistics are displayed on the screen, users can use the export feature to download the data in a variety of formats, such as CSV or Excel. To do this, users should click on the Export button, which is located near the top right corner of the statistics table. From there, users can select the desired format for the data and then choose to either open the file or save it to their computer. After downloading the statistics, you can then use the data like how we've described in other parts of the course. That is, open it in Microsoft Power BI and begin creating your dashboards. The second method is manually downloading the data from mysportsfeeds.com. As we've mentioned earlier in this course, mysportsfeeds.com is a website that provides access to a wide range of sports statistics, including hockey statistics. Users can access and download these statistics using the manual download feature on the website, which allows them to customize the data they want to download. To use the manual download feature on mysportsfeeds.com, users should first navigate to the website and create an account. Once logged in, they can select the desired sport, which, in this case, is hockey. From there, users can select the type of data they want to download, such as player or team statistics. Once the desired data is selected, users can choose to download the data in a variety of formats, including CSV, JSON, and XML. They can also select the period for the data, such as specific games or seasons, and filter the data by various categories, such as player position or team name. After selecting the desired data and filters, users can download the data to their computer or device. Once downloaded, the data can be imported into Microsoft Power BI, as we've shown before in this course, for analysis. Overall, the manual download feature on mysportsfeeds.com provides users with a powerful tool for accessing and downloading hockey statistics. While the first 2 methods are simple and allow you to quickly and manually access sports data, the third method is more programmatic. This means you need to embark on some coding to create an application. However, there are many benefits to you doing this. For example, you have more granular control over how to wrangle and structure the sports data. You can automate the retrieval of the data. You can integrate different data sources to do more advanced analyses, and so on. Also, if you're looking to do more data science and AI, analyzing sports data is an excellent and fun way to start your skills development here. That said, MySportsFeeds.com provides you with a web-based API that programmatically accesses a wide range of sports statistics, including hockey statistics. Users can use this API to download different types of hockey statistics, such as player or team statistics, and then use Python to normalize and persist that data as CSV files on disk. To begin, users should create an account on MySportsFeeds.com and obtain an API key. Once they have the API key, they can use Python to send HTTP requests to the API endpoint and retrieve the desired data. The requests module in Python can be used to send HTTP requests, and the JSON module can be used to parse the JSON data that's returned by the API. Also note that if you choose, you can access the hockey data in XML format as well. For example, to retrieve team statistics for a specific season, users can send an HTTP request to the team stats endpoint, specifying the desired season and other parameters as query parameters. The response from the API will contain a JSON object that contains the team statistics for the specified season. Once the data is retrieved from the API, users can use Python to normalize the data and store it as CSV files on disk. This involves parsing the JSON data into Python data structures, such as lists and dictionaries, and then writing the data to CSV files. When you programmatically access the data, you may also want to filter and normalize the data. Filtering the data is the process of selecting only the data which you want to analyze. Normalization is the process of organizing the data into a structured format that can be easily analyzed and queried. By leveraging the flexibility and power of Python, users can create customized datasets that are tailored to their specific analysis requirements and can use these datasets to support a wide range of data-driven decision-making tasks. If you remember back to the earlier lecture on the conceptual architecture, we covered two major components. One, web-based hockey data, and two, the retrieval of that data using Python. In this slide, you can see we've highlighted these two components in the conceptual architecture to refamiliarize you with where the Python code is situated and the fact that it runs against MySportsFeeds.com. Again, the code was written to talk directly to MySportsFeeds.com APIs, but you can extend the code to talk to other data sources or use a similar approach to have multiple Python scripts that leverage different sports APIs using MySportsFeeds.com. For example, you could have a script for NHL data, NFL data, and so on. Let's talk a bit more about the nature of the Python code, specifically the steps it takes to retrieve team stats and the Python application syntax. There are two Python resource files included with this course. One can be used to programmatically access team stats data, and the other player stats data. The semantic structure of the files are similar, so we'll walk through the team stats resource file in this lecture, and you can review the player stats resource file on your own time. Note that we've coded up the basics in these applications, so think of the code as demo code. For a production quality deployment of code, you'd want to include error handling, unit tests, and so on. But for the hobbyist to learn how to build and deploy a Python application, getting the demo code to work is a good first step in your learning journey. The team stats Python file is roughly split into 6 working parts. The first part of the Python team stats application involves declaring the libraries that will be used in the code. This is important because it allows the program to use functions and features that are not built into the base Python language. The next part of the application involves setting global variables. These variables are used throughout the code to store information that will be used multiple times. The third part of the application involves creating the column headers for the data frame that will be used to store the team stats data. This is important because it allows the program to organize and manipulate the data in a structured way. The fourth part of the application involves retrieving the team stats data from the MySportsFeeds.com API using the requests library. This involves constructing a request URL that includes the API key, season, and league variables, and then using the requests library to make a GET request to the API endpoint. The data returned by the API will be in JSON format, which will be parsed using the JSON library to extract the relevant information. The fifth part of the application involves creating a data frame and populating it with the team stats data that was retrieved in the previous step. This involves creating an empty data frame with the column headers that were created earlier, and then iterating through the JSON data to extract the team name and relevant statistics for each team. This data will then be added to the data frame. The final part of the application involves writing the team stats data to a CSV file using the pandas to CSV function. This function takes the pandas data frame and writes it to a CSV file that can be easily opened in a spreadsheet program like Microsoft Excel. The CSV file will be saved to the current working directory, and the file name will be dynamically generated based on the season and league variables. Let's explore each of the above steps by describing the code snippets within each step. The first Python code snippet is very straightforward. It imports several libraries that are used in the script. The first library imported is base64, which provides functions for encoding and decoding binary data in ASCII. In this code, it's used to encode the user credentials for accessing the mysportsfeeds.com API. The requests library is used for making HTTP requests to the mysportsfeeds.com API to retrieve data. It provides methods for making HTTP GET, POST, PUT, DELETE, and other types of requests. The JSON library is used for encoding and decoding JSON data. In this code, it's used to decode the JSON data returned by the mysportsfeeds.com API into a Python object. The pandas library is used for data manipulation and analysis. It provides a powerful data structure called a data frame, which is used in this code to store and manipulate data retrieved from the mysportsfeeds.com API. Finally, the shuttle library is used for high-level file operations, such as copying and deleting files. In this code, it's used to clear a list from memory. This next code snippet defines the endpoint URL, username, and password for retrieving data from mysportsfeeds.com API. The poll URL variable holds the endpoint URL of the API that contains NHL team stats. The myUsername variable holds the username for accessing the mysportsfeeds.com API, and the myPassword variable holds the password for the user account. The next code snippet defines a list of column headers to be used in a final data frame for the purpose of analyzing NHL team statistics. The column header consists of strings that represent various team and game statistics such as wins, losses, overtime wins, power plays, penalty kills, shots, and more. These column headers are used as labels to identify the data associated with each statistic and are organized in the same order as they appear in the JSON response from mysportsfeeds.com. You may choose to use even more lighter strings, for example, acronyms, for the headers. This is entirely up to you to customize. Having a predefined list of column headers is beneficial for data analysis because it ensures consistency and accuracy when storing and retrieving data. It also provides an easy-to-understand structure for the data frame and makes it simpler to refer to specific pieces of data within the data frame. In addition, using a standardized set of column headers allows data to be easily merged with other data frames that have the same structure, facilitating comparisons and analysis. The next code snippet defines a function called sendRequest that sends an HTTP GET request to a specified URL using the requests library in Python. It includes the required authentication information in the header of the request, using a base64 encoding of a combination of username and password. The function includes a try-except block to handle any exceptions that might arise while sending the request. This next code snippet is a for loop that iterates over 32 team statistics data and extracts the necessary information for each team, including team metadata and team stats. The final code snippet above clears the team stats summary list object and writes the team stats summary data obtained from the API to a CSV file. And if you're new to programming, you may wonder why we've shown you 3 different ways to effectively do the same thing. The reason is simple. If you want to get the data quickly and simply and don't want to fuss about with any code, you can navigate to the resource and download the data. And if you want more control, or you want to extend and build on or automate your data retrieval, wrangling, storage, and analysis, then perhaps programming against the API is a better choice. You can ideally start with manual and then proceed to programmatic. That said, the result of the manual export from NHL.com looks like this CSV file. You can see here that there's actually plenty of data you can use to analyze. The data is also broken out by teams and even has a combination of raw and calculated statistics in it. Conversely, the mysportsfeeds.com manual download has more columns with a bit more metadata. One note for us, and why we programmatically access this data, is that when you download, you inherit the naming conventions of the source data. When downloading the file manually, you can either rename the column headers yourself in Excel or do it in Power BI. For us, we wanted to automate this process so anytime we retrieve a file, we save ourselves the extra step of renaming the column headers and filtering to the ones that we want. This last example is the result of the Python code that we just walked through. Here, you can see that the structure of the data maps to that which we set out in our code, and the column headers also map to our conventions. An important note on the programmatic side is that once you programmatically retrieve the data from a source like mysportsfeeds.com, you can also add your own calculated columns and statistics that may be specific to your needs. For example, you typically don't have Corsi or Fenwick statistics available to you in statistical feeds, and you may be working on your own innovative statistic that you want to use for your own fantasy hockey or analytical needs. Using Python, you can very easily add calculated columns and then have this available for use in Power BI or other BI tools. In this lecture, we walked you through different ways to retrieve hockey stats data. Using each method, you ended up with a CSV file with different team stats data in it. You can use these same methods, manual or programmatic, to get all sorts of data, which you can then analyze. In our next lecture, we'll take the data you've now retrieved and spend more time in Power BI building an analysis of that data.